Hey guys, just a few minutes ago, we integrated this problem, this function, and ended up with 1/2 natural log of e to the 2x plus e to the minus 2x plus c. Now in this video, we're going to take the derivative of this to see if we can get back to the function we started with. All right, so let's get after it here. All right, I personally like to take that 1/2 and put it back where it makes sense to me. Now we know we're taking the derivative, the constant is 0, so we'll wipe it out. But if I have, for example, 3 natural log of a, I can rewrite that then as the natural log of a to the 3rd power, which is where that 3 came from. And then when I take the derivative of that, if I take the derivative of this thing with respect to a, I have the derivative of a cubed over a cubed. So I would have 3a squared over a cubed. So I'm going to do the same thing with this function. Sorry for my sloppy writing there. All right, let me get rid of a few items here so we'll give ourselves some room. Okay, I'm going to rewrite this with the 1/2. So I've got the natural log e to the 2x plus e to the minus 2x to the 1/2. And all of that over, or the natural log of all of that. Okay, so if I take the derivative of this with respect to x, I end up with a derivative of this function over that function. So I'm going to go ahead and write the function down first. E to the 2x plus e to the minus 2x to the 1/2, which is what? Square root of that. Okay, now the derivative of this guy, in the chain rule, I'm going to wipe this out right here. In the chain rule, if you're trying to take the derivative of a function that has some inside parts and outside parts, which is what we have here. We're trying to take the derivative of e to the 2x plus e to the minus 2x, all raised to the 1/2 power. So I need to take the derivative of the outside function first, and then the derivative of the inside function next, and multiply those together. That's the chain rule. So that's what we're doing here. So I have 1/2 times e to the 2x plus e to the minus 2x. And then I decrease the function by 1. So 1/2 minus 2 over 2. 2 over 2 would be 1. Gives me minus 1/2. Now let's take the derivative of the inside. So I have there's the sum difference rule when you're taking derivatives. I can take the derivative of this piece and plus the derivative of the other piece. That's the sum rule. All right, so the derivative of e to the u is e to the u du. So I would have e to the 2x times the derivative of 2x, which is 2. So 2e to the 2x. Okay, then the derivative of e to the minus 2x is minus 2e to the minus 2x. All that dx. Okay. Wow. All right, let's reduce a few things here. First, let me just factor the 2 out of that. 2e to the 2x minus e to the minus 2x. Okay, we got that. Now, since this is to the 1/2 power, I'm going to bring it down to the denominator. Now I have this same thing times itself. So You know, a to the m times a to the n is a to the m plus n. So I have here, in this case, we'll call this thing a to the 1/2 times a to the 1/2 gives me a to the 1/2 plus 1/2, a to the first power. Sorry for some of the simple algebra there, but so those, you bring it down, you end up with e to the 2x minus e to the minus 2x, plus e to the minus 2x. Okay, and I had a 2 here and a 1/2 there. So there's my 1/2. Ooh. So that should look like this. E to the 2x minus e to the minus 2x over e to the 2x plus e to the minus 2x. So we've confirmed that that answer that we had gotten earlier is in fact correct. Okay, we say at every video, keep studying. And why are we doing this? Together we're trying to build a better tomorrow through math. Keep studying. Work as many problems as you can work. It'll keep your mind strong, okay? All right, that's all for now. Talk to you next time. Thanks.